Hi, good morning, and welcome to my shop here. It's a very hot July 19th. It's hot. It's going to be about 30 degrees here today, which is not out of the norm. That's not outrageous, and I know lots of people in the world are suffering from outrageous heat, especially in Europe and other parts of North America, and probably elsewhere in the world I'm not even aware of. So I'm not complaining here, but it's a hot day outside. So now, I like to work on these radios in a way that I find interesting and exploratory. I'm not inclined to just get in and start replacing parts willy-nilly. I much rather have some kind of approach thought out that I think is going to provide some interest and some fun to me and to you also if you're enjoying this kind of stuff. So what do we got here? We've got a radio where the broadcast band seems to work fairly okay, but none of the 4 shortwave bands appears to work well at all. The sensitivity on the shortwave bands appears to be very, very low. They're working, but very low sensitivity. So how can that be? How can you have this band receiving seems to be okay? When I turn to this band, the noise level is very high. The sensitivity is apparent. When I go to any of these bands, I got to turn the volume way up to even hear a bit of a hiss. The sensitivity is very, very poor on these bands. What's the difference? Well, certainly the circuitry is quite different between the broadcast band and the shortwave band at the front end of the radio. Once you get to and past the mixer tube, it's all the same from there. So if the radio's not working on certain bands, it has to be because of the stuff in the front end. And what is in there? Well, what's in the radio? There are a bunch of old capacitors, any one of which could be knocking out the radio, or all of them collectively can be dragging down the signal strength. That's dramatically different between the broadcast band and the shortwave band. It makes me think it's going to be 1 or 2 components, and I wonder if I can track them down. I think that might be interesting and fun to try to figure that out. Is there 1 or 2 components I can find, a capacitor most likely, that if I replace that, the shortwave will be almost back to normal? That's a good question. Another thing is, are there more tests I can do on this radio to try to home in on where things go south in here? Now, I've got a couple of signal tracers in my shop. You can listen to a signal as it works its way through the radio. But unfortunately, they're both designed for just broadcast band radios. They won't work at the higher frequencies for the shortwave band. So I can't use a signal tracer, which is kind of unfortunate. I guess I could use my oscilloscope, easy enough. Observe the signal, say on the antenna, and then observe it, as it moves through the radio. It's supposed to be getting stronger, but at some point it's disappearing on shortwave. It also has to be, it cannot be any of the components that are specific to a band. So as you turn the band switch, you're selecting different coils and different capacitors, some combination sometimes. So all of them are behaving the same. So there can't be anything specific about that. So that kind of suggests the problem lies between the antenna and the first switch. Well, that's not much in the radio. Let's take a look at the schematic and see if we can get more confused about this. Okay, let's look at the schematic. Now, unfortunately, I made a video error twice in a row here. I'm repeating what I'm about to do here with the schematic. So, I think the interesting thing about this is the fact that broadcast comes through and shortwave does not. So just looking at what is different between the shortwave and the broadcast. So here we have the antenna transformer down here, and all this, and this part is the broadcast part, and this part is the shortwave part. So trouble here wouldn't necessarily affect the broadcast part at all. So there's a difference right away, and it's often the case here that the shortwave radio is really a radio, the same sort of circuit, just being tuned differently, but the broadcast band is handled differently. a little bit different at the front, in the front of the radio. So it's kind of like two front ends here, the broadcast and the shortwave. If you look past this tube, you see the same arrangement here. Here's the shortwave, again, transformer, and here's the broadcast transformer. So there's really kind of a broadcast circuit separate from the shortwave circuit, but not really. Both signals are fed through this tube. So you would think if a strong AM signal here can come out strong in the speaker, a strong shortwave signal here would do the same thing. Well, maybe not. Maybe there's trouble here or in the components that are associated with it. Look, it goes down into the switch. Somehow it's got to get onto the grid of this tube. This is the converter tube. It actually has two grids. Things are getting a little complicated. Can't see what's going on in the tube because the copy is so bad. But I'll bet you this is the wire that is bringing up the output, if you like, from this tube and this transformer along this wire. So here's a capacitor that's common to both. The thing is that at this point the frequency is quite different. At this point the broadcast band frequency is low, around 1,000,000 hertz on the broadcast band, and the rest of the shortwave bands are multiples of 1,000,000, 9 million hertz going through here. So maybe the lower signal's getting through, the higher one can't. It's actually kind of backwards to how a capacitor works. So, but the way I would look at this at this point is this is a common component, and so it cannot be responsible. It's common to both AM and shortwave. It can't be responsible for the problem we're having. So that really throws us back here to this transformer or this transformer. That's not good. I don't like that. The broadcast signal also comes up this line along with shortwave when shortwave is on to find its way into this tube grid through this. This is also a common component. If it works on broadcast, it should be working everywhere. I think what we should do is check the signal strength coming out of this tube. This tube's job is to amplify the antenna signal. Maybe there's trouble. Maybe we can isolate the trouble better or localize the trouble better. So we'll look on the plate. Here's the plate circuit. Take my oscilloscope. I cannot use my signal tracers except on broadcast. They don't work on higher frequencies than the broadcast frequency, so I can't use it on shortwave. So we'll have to use the oscilloscope. So we'll look at the signal strength coming in. We'll put on broadcast band. We'll look at the signal arriving and the signal leaving, and we'll flip it to shortwave. I'll be pumping in a signal from a signal generator. We'll know what the signal is here, and we'll see what it is here. It should be higher. It should be there, and it should be higher. And maybe that'll give us some insight into what to try next. Okay, ins and outs on the 6SK7. The 6SK7 tube is right up here. This is there's two 6SK7s, so this is the RF amplifier tube. It's right here. Pin, let me practice. I've got my oscilloscope just about ready to go. Let me put this on a ground. And then we're going to want it. The radio's switched off so I can practice. So I don't can put it like that. Now that's the plate, that's the output. Trying to see it on the grid may have its problems. The grid would be pin 4. Pin 4. The reason is hooking up equipment to a grid usually disturbs the radio. Pin 4. So if we count 1, 2, 3, 4. This is 4 here. So I've got 8 and 4. 8 and 4. Interesting, they're on opposite sides of the socket. The plate and the grid. And that's not by accident. They don't want any of the signal that's coming out of the tube to work its way back into the tube. So to keep everything as far apart as possible. Even the pins are arranged with those kinds of things in mind. Okay, so we want this on broadcast. We want to feed in a broadcast signal using the signal generator. Broadcast signals way down here. We'll put it towards the middle of the band, so around 1,000,000. And that signal strength to be set to a good strength. Okay. And volume turned down. Switches on. Tone turned up. Signal fed in. Okay, so I've instead of clipping it on these, which are always a little bit unreliable, I've clipped it right on the terminals at the back here. The signal's passing through this capacitor that is bypassed with this wire for reasons because this goes to an internal cabinet internal antenna. And because it's a cabinet internal antenna, it doesn't require the capacitor to protect it and ultimately protect people, which is really why that capacitor is there, I'm pretty sure. Okay, now we're able to tune this radio because the pointer moves. Wow, that's great. Let's move that pointer right around 1 million. Okay, so that's tuned around 1 million here. We're all set to go. I've also, to improve my own safety here, I've soldered in a plug. So you can see it here. It's soldered in and taped. It's no longer clips. Okay, there you go. Dim bulbs, always dim bulbs. There she goes. Okay, dim bulbs are dim. That's good. I don't like this hanging here like that. I'll make it hang there when I need it. Volume up a bit. And I better tip up the speaker over here. Here just a little bit better. Previously I had the speaker facing up, which is a no-no. It's a no-no. Even having it like this isn't 100% safe. But facing up, it's like a cup waiting for something to fall into it and rip it. So shame on me for having it face up there for a while. Where's the radio? Very, very quiet. Oh boy, we're off to it. Okay, low voltage. Full voltage. Not a lot there, but it's all dependent upon the signal coming from here. Oh, that's what's happening. Wow. So bypassing that capacitor raises the sensitivity hugely. Is that true? Let's do a stupid test here. Stupid test. Who needs equipment? We don't need any equipment. The finger will do. Wrong one. Does that sound the same? Not quite. Capacitor is dropping it just a little wee bit. My previous test by squeezing the two wires is not really. It's not really true. Okay. Wow. Enough fool. I like to fool around. So we're hearing the signal already. Well, that's why it's a little weak. It wasn't tuned in. Okay, down on the signal strength. Funny clicks and pops coming out of this radio. So that's tuned in pretty good there. What is going on? There's some weird stuff happening here occasionally. Okay, now, oscilloscope. Okay, you can see it from there. Oh my gosh. No wonder it's so bright in my shop. And more light on than I realized. Now I have a new, somewhat new automatic light way up in the ceiling there, way up there, that glowing thing. Do you believe you can't turn it off? If I turn it off, the moment I move it comes back on. Too complicated, everything. Even the lights are complicated these days. Oh my gosh. Now we're going to want to measure the signal at the antenna to start with. See what we can see here. Okay. We're on the times 10. Oh, no wonder we can't see anything on the scope. Let me turn it on. Probably a very weak signal. Let's put this on ground. Where are you? There you are. Put it right in the middle. Whoops. AC. I'm going to jump the level up because it's actually very low. Go up another shot here. Now that's a very strong signal being fed. Well, we can definitely see it here. It doesn't look quite the way I would want it to look. The actual, I'm not going to get it stopped, but so this zigzaggy part you can see, that shouldn't be there. Now, how come you won't trigger? I won't spend too much time bothering with triggering it, but it won't trigger. Because I'm on channel 1. There we are. Wow, it's still shaky. Yeah, something funny going on to give it that kind of shake. Don't really hear that in the speaker though, I don't think. And the tone you're hearing is coming from the signal generator. Okay, you can turn the volume down here. Now we take a measurement of the signal strength. That's the input signal strength to the antenna from the signal generator. And it's 1, 2, it's roughly three divisions from peak to peak. And on the other side of that capacitor. I'll explain that one. How to get higher. Get it on there. Put it up here. You know what? I can go on this wire. Wow. Well, I don't know. The other side of that capacitor, the signal appears to be way stronger. How does that work? Some kind of resonance on the other side of that capacitor. We would see an effect maybe if I tune the radio. So we're watching the width of this. Well, there is a little bit of an effect there. That's pretty interesting. It's interesting because I have no idea offhand why it's doing what it's doing. Now I get a much better view of this with my eye than you get on the screen here, but at a certain tuning frequency, I think that maybe that's an oscillation in there. I'm tuning an oscillation through it. It certainly is what it looks like. Can't hear it though, so it could be supersonic, above your hearing, or it could be the opposite. It could be so low in frequency we can't hear it. Or is that, you know what that is? That's probably the modulation from the signal generator. That's probably what I'm seeing there. Let me vary the modulation level here. Oh yeah, that's what it is. It's nothing. Okay, once again wait a minute, there's no modulation now. Okay, modulation's completely turned off. My so far out of calibration here. Okay, mysterious observations, just of general interest, not really helping us much. Now, am I looking at the signal coming out of the signal generator? What has happened? I've totally lost it here. Completely lost it. That's me grabbing the antenna. This radio is really trying to receive. Okay, once again, input. Nothing on the scope. I gotta change my I gotta take a little break here. Things seem to be going totally haywire. I'm gonna take a little break and change my camera arrangement, make this a little easier on everybody. Okay, let's give this a try. Look at this. Okay, nothing on the scope. Signal coming in from the signal generator. You can't even see anything happen on my oscilloscope. Signal on the other side of that capacitor. What? Disconnect the signal generator. There's no signal generator signal anymore. What's that? What's going on here? There's something there. What is there? Why would there be a signal there? Just make it a little more visible. What's that doing there? Okay, first I'm going to turn off the radio and see that it disappears. Does it disappear? Oh yeah. Now I'm going to change bands on the radio. Keep the volume down. We'll see what happens to it. So this would be top shortwave band. And I say top. It's not. Yeah, that's a dangerous term. Coming back down. That's broadcast. That's the first shortwave band. Well, there's another possibility here with this radio being weak, because on the first shortwave band, I think I was able to pick up 9.3, and on the rest of the bands, it was just about nothing. So what are we seeing here exactly? Looks like the same frequency. Let me speed this up. Let's see if we can. So there's the actual frequency. That's broadcast. See, the frequency has changed a lot. I'm going to tune the radio and see if this frequency changes here. Yes, it does. So I think what we're looking at is the local oscillator coming back out of the radio, where it's developed in the radio, and working its way in the wrong direction back to the antenna. And we're seeing it here. So that in itself isn't a problem. What's a problem is that's broadcast band. The local oscillator is pretty strong. What happened to it? Wait a minute, this is working even weirder. Hey, now, did everybody see that and hear that? Briefly, this got a little taller. Oh, wow, that's magic. Can I do that again? No, it didn't work again. That got taller, and this thing sounded like a radio for a moment. Oh, there's smoke coming out of the radio. There's smoke coming out of the radio. Son of a gun. Smoke coming out right in here. Son of a gun. Son of a gun. Well, I think we're getting closer to the problem. Well, where did that come from? So I saw wisps of smoke coming up right in here. I gotta get my thermal viewer out really quick here. Okay, gotta run and get my thermal viewer, get that going. What burned? Well, it's been like 5 or 10 minutes since the conflagration took place in here. So here's my thermal viewer. Now I haven't set it up at all. The temperature settings are whatever they are. I haven't even looked. But you can see right away that there's lots of heat still inside the radio that can be picked up with this thermal viewer. Now, knowing exactly what you're seeing on the screen here is not easy with this guy. Just heat everywhere. But I can change the settings now on this to make it less sensitive than what it is. So we'll make things turn red at, say, maybe 60, say 50 degrees. Okay, so anything at 50 degrees will turn red. You can see the red has disappeared already. The lower temperature is 25, so this blue you see is 25 or less. That's fine. That should work. Now, is there any heat left up in here? I don't see anything. There's lots of heat here, but see, these are tube bases and they've warmed up. And then this is the transformer here. A little bit of heat. I can feel the heat in it. My finger, actually, it's quite distinct. My hand is actually cool enough it doesn't even show, just based on the settings here. Okay, so what are we going to do? We're going to turn this radio back on? No, first we're going to examine it very carefully and see if we can see what caught fire. Well, nothing caught fire, but this is a great device. Not very expensive. There's all kinds of them out there to get. Well, let's see, I saw the smoke come right up here. The first and most suspicious thing is this coil right on the top here. Here's this wire to nowhere. Was that what happened? Smoke came out of it for somebody else and they cut a wire and that was their solution? We still don't know what this wire is all about here. Can't imagine a cut wire is leading to a smoking coil. But to get the close-up camera and take a very good look, very close look at that. Now, bear with me for a minute here while I just want to make sure that I've got the camera focus set where I want it to be. Yes, it's fixed. Focus. Focus, focus. Okay, the smoke zone. Quite suspicious right on the top where there it looks like there's a melt has occurred right in here. This, not the wire you can see, but the other one. Where's that going? Seem to go anywhere. Okay, let's pick at it. I gotta change hands here. In fact, I gotta fix this camera in place. This might just take a moment to find a way to have it sit here. Well, that's pretty good. We just fix the focus on it. Don't fall, camera. Well, we can't quite see the piece I was going to poke at. In this angle, we can see one wire lead here. This way. Tuck it like that. There. What are we looking at? Coil we're interested in is this one. Yep. Let me just fix the focus again a little bit. So what we're looking for is an area that obviously got hot. The fact that smoke was coming out and continued to come out until I hit the switch suggests that whatever was getting hot didn't burn open and stop. You can see here, very hard for me, right there. There's a line in the wax or whatever material it is that's on top of here, as if a wire was laid there at one time. This funny mark right here. Let's look down the back side. I'm just going to change the focus so we can see down the back a little better. I don't see anything. Now, is it necessary that we can see this? So I think if the smoke were coming right from the top of this coil, I would have noticed, I would have seen that. It seemed to me to be coming from down the back here, and I would guess from even below, even further below. Well, let's go way down there with the focus to see what we can see down there. Not a lot. A lot of wires. And wires don't smoke. Coils smoke. Okay, so now we have two things. We have a weak shortwave receiver and smoke. What makes a coil smoke is too much current going through it, and what makes too much current go through it? Not this guy. Oh wow, that's scary, eh? Come on, get a move on. Ooh, I poked him, he's gone. Where'd he go? Oh jeez. I don't know where he went. Okay, yeah, black ants. Here he is. He's over here now. Black ants. I guess my chemical warfare is worn off. Don't put it there. Don't put it there. Let's look in different angles here and just see what we can see. Maybe we'll see something. Bottom of that coil looks pretty weird. It looks like that. What is that? Looks like, is that tape? Tape they've put around it? Maybe they did, because you see they're peeling one wire out there. They may have applied tape to kind of. Wow. My thinking here is I'm not going to find it this way. It's just something you really need to do. Look for these things. I have to turn the set on and try to identify where the smoke is coming from. That capacitor looks pretty weird. Smoke from a capacitor like that. Well. Hard to understand how a capacitor would smoke, but you know, anything's possible. Well, even further down. Oh. The heck is all that? Well, this looks like something that took some heat. What am I looking at? I'm looking at a capacitor here. Okay, so that's possible. That's in the right place. That is really ugly looking. Look at that. What is going on with it? So what I can do is I can operate the radio, restrict the power going into it, and then look for the source of the smoke. Now once we get down here, it's a long ways down to the next stuff, and I would have seen the smoke coming from down here, I'm pretty sure. pretty sure I would have seen it. Nothing looks burned up. It's way too low. So what do we got? We got maybe a coil. We got who knows what back in there. Maybe this capacitor? Look at that thing. Okay. What I am going to do, I'm going to set things up here so we can keep track of everything when I turn this radio on and spot what the problem is. So I think just the set is not on. I'm just practicing here, so still have my scope in here. Could it be part of the problem? Can't imagine it. But let's get it out. So we're not. Okay. No signal into the radio antenna. It's just radio. You can see I have this camera looking straight into the zone. This is so you'll be looking through this camera for smoke. Meanwhile, you won't be able to see me doing this, but I'll have this guy going, and I'll be quickly trying to identify where the heat is coming from as the set warms up. It wasn't one of these turn it on and away she goes. This was a slow heater. That's what I think anyway. Oh my gosh, really? Peanut? Now? You want to go out? Yeah, that's a yes. Okay, I have to go let this cat go outside. Poor guy. Okay, I think I'm ready for this. The only reason I'm doing this is because I believe if the coil is not burned open at this point, I'm not going to burn it open by doing this. Otherwise I wouldn't do this. It's all about using restricted power and assuming there's a heating time involved. Okay, so I'm liable to shove this right in front of the camera a little bit while I do what I'm doing. Here we go. Okay, power's on. Dim bulbs are doing their thing. Watching for smoke. Any sounds. Any evidence of heating. I switched the band. I think I quickly switched the band to AM in a panic there. And nothing at all is heating up here. That's good. Okay, I'm going to turn the volume up. There's nothing coming out of it. Let me put my finger on the antenna. Ooh, she's nothing. Okay, there's no smoke visible. I'm looking on the camera too myself. No smoke, no heat buildup. That's not good. We want it to repeat itself. Okay, a little bit of heat visible away in the other part of the radio. There's just nothing heating up here at all. No evidence of smoke whatsoever. No heat. Okay, which band am I on? I did not set it to broadcast. So it's still on shortwave. One particular shortwave band did this? That's not so likely. There's just nothing happening here. I'm going to make my thermal viewer more sensitive. So now anything that's even 30 would show up. So there's a little bit of heat up here. What are we looking at? So there's the little camera right there. We're looking right at this coil. Okay, hold still for a minute. Keep moving. Very tricky to figure out what you're looking at in these cameras. I think it's that coil. We'll just keep it going here. The temperature you see at the bottom of the screen, 24, 26, 25, that's showing the temperature of the plus sign. Whenever I put the plus sign on by aiming the camera, it will tell me the temperature of it. Darn tricky thing to do. Plus, there's also, bopping around on the screen, there's a red plus and a blue plus bopping around. A little hard to see in the camera. And every fraction of a second, they're marking the highest and lowest temperatures on the screen. And those are reported here, min-max. You see the maximum temperature on the screen right now is 27, 28. That's nothing. That's not going to smoke anything. There's nothing happening here. This is not a good sign. It's a sign that whatever was hot burned open. So we have that much heat in the coil. Is there any other coil doing the same sort of thing? And you wouldn't, I think, generally speaking, you don't expect any heat in any of these coils. That's what I would think. Well, see, it's definitely building up. Now, is that for sure that coil? So what I'm going to do is I'm going to block the camera's view of the coil with this stick. So I'm gonna just might bring this stick down in front. You see that? See how it disappeared? As I move the stick across the front. What am I looking at? I'm looking at the light bulbs way over yonder there. Okay, back on the coil. Now I'm going to start covering the coil. Hold still. So that's the coil covered and uncovered. So the coil is getting warm. Now, is it actually the coil? There's a wide angle view on this camera, and that's what makes it so tricky. Oh, it's got to be the coil. It's got to be the coil. So I'm looking. Where am I looking? Again, wide angle really makes this tricky. So sorry this isn't the best thing to watch. Since there's no smoke to see, I'll give you a wider view here. Looking down. Things are getting warmer, that's for sure. And I'm really very certain I'm looking at that coil. Now, can we tell where on the coil? There's two coils on there. A bunch of other stuff. Down below here, that weird looking capacitor is not showing any heat at all. I would think you can't get smoke till you're seeing a lot of red on this screen. It's just slowly getting hotter and hotter. Should I, and what is the temperature now? It's still low. 20, it's not even 30 degrees. So that's not terribly high. That's how hot it is outside right now. My cats are loving it. Cats are desert animals, you know. No other coil showing any heat. Okay, let's stop at this point. We'll go under the theory that this is a lousy pointer. This is better. Power's off. This coil is overheating. Not because there's something wrong with the coil, but because there's something wrong with the component near it. Look at that thing. Great big capacitor sitting right here. There's probably some other capacitors here and there. Let's look and see if we can figure out if there's a capacitor connected, associated with this coil, that if it were to short would cause a heavy current through the coil. Or let's just see if this capacitor is shorted. That's an even easier way. Let's do that. So a short-circuited capacitor, okay? There's a short circuit. We're going to hear this. What's this guy? No. No. Just fooling around. Doesn't mean it's a short because it's in a circuit. If it doesn't make the sound, then that's pretty good evidence that it's not short. Now what about this one down here that just looked like it got dragged by the car or something? Can I even make contact? I can't be sure the other end of that capacitor where it is. Just move this out of the way. So this capacitor is connected to this coil. I find the back of my finger is sensitive to heat, better than the pad of my hand. I don't feel any heat in here at all. Could have all dissipated by now though. Aren't you worried about charged capacitors shocking you? Not really. Okay, let's find this coil on the schematic. Oh, there's another capacitor back here. There's another one. Now, I don't know that these are connected to the coil. They're just local to it. There's a good chance they are. Okay, so this one comes out here, and the other end is right here. Okay, don't hear anything. Nothing appears to be shorted out. Now, it's also possible there's an intermittent short. Given enough time, the short will develop. And that's when the smoke gets flying. Schematic. Let's see if we can figure this out. Okay, so which coil are we looking at? Now, this coil looks like it has two windings on it. It's in the, I'm not sure what to say, if that's the intermediate. I don't know where it is in the circuit. Two coils on it. Well, that's two coils. That's two coils. This is almost certainly separate from this. They wouldn't want these too close together, I would think. The upper one has a pile of taps. Okay, so I think I see all four of these coils, or transformers. There's one here, one here, one here, and one here. And I'm looking in the radio, and I think I see all four of them. If that's the case, then the ones I'm looking at would have to be either... This doesn't make sense, actually, what I'm saying. It have to be either this one or this one. It has to be the broadcast coil. Remember, when we snap it to shortwave, this ground goes on. Probably the same thing's happening over here somehow. And we put a ground on right here. There's really no way to burn these out here in my shop. So whether the ground is on or not shouldn't really make a difference. These two guys here, they have this symbol. And that would indicate like an iron core, but I can't imagine there's an iron core on these. Why do they have this symbol here? See, over here they show it variable, but again what? So those ones do have a moving core that is adjustable here. So there must be a core inside that coil. I don't know. Maybe. Something going on. Well, assumably there is. It doesn't really matter. Now, let's start with this one. And you know what? This is not... Yeah, I can't be sure. I was going to say I can tell which is which, but I can't yet tell which. So one of these is the one we were looking at. One of them, according to this diagram, has more turns on it than the other. So it would be, if that's the case, this is the one. This is the guy who appears to have cooked up. Now, look at this. This is hooked up right to the plate. See, you have plate current flowing through here, so these should warm up a little bit. Now, if you had a wow, oh, down to ground. So if you switch this not where it is now, this is shown in broadcast, and this part of the switch is open. But if you switch it to shortwave, a ground is placed on this wire on the other side of this capacitor. If this capacitor were to short, then that would pull a heavy current through here. But not through here. This is where we think the smoke is coming from. Currently think the smoke is coming from here. Okay, so how do you pull a heavy current through here? So it can carry on, carry on, carry on. So you're getting back to the power supply here. You're right back to the source of the power. So there's like a couple hundred volts right here. A couple hundred volts all along here. A couple hundred volts. So that wouldn't, so if you're going to pull current through the coil, the fault has to be on the far side of it. It has to be up here. You have this guy. Now what if this guy shorts? This guy shorts out. You then have attached, well, you've got a big resistor here. I can't read that. You have a resistor here to ground. The other way, you have a capacitor. Get back into these coils, and there's another way. Where to go? I'm losing myself here. Down here, down this line. Oh, it's going to go in the switch. Looks like it's associated just with this. Come back up. Oh, I'm losing it. Back up. We have a capacitor here. It's going through that same resistor. I'm looking for any capacitor that would short and introduce a ground on the coil. It didn't work very well. So we've operated the radio with a low supply, and we saw no smoke and no heat. You know, at this point I could just say, well, maybe it's one of those capacitors I can see in there and get after them all. And that might do it. How would we know? For sure, since I've operated a radio with no smoke at this point. How do we know these coils are even continuous? I mean, I could test them, but that's tricky too. Do they have coil diagrams here that show the terminals on the coils? Not on this page. Data sheet 106. So that's a possible ohm out these coils and look for something that's gone open. But I'm operating on the theory it didn't go open. It just got really hot. One particular band is introducing a problem. And I happen to be sitting on that band when the smoke came out. Is that possible? So as we switch through the bands, we're selecting different coils in here. That doesn't change very much, really. Changing shortwave band, changing to broadcast band changes a fair bit, but you're just kind of selecting which coil you want to use here. Can't see that. I can't see that happening. Now, I was also in the verge of determining the local oscillator was weak. In fact, that's just what I was homing in on when the smoke appeared. Local oscillator, through a rather poor test, seemed to be weak as we went up in frequency. And then the smoke came. Well, I'm a little stuck here on what to do exactly. I have to make some decisions here around. Start replacing parts in the area that where the smoke came out and hope I just luckily hit the one. And then carry on after that. That's not nonsensical. Carry on with more testing, more observation. What am I going to find out there? You know, what's going to happen here is I'm going to change a bunch of capacitors, not know for sure if I've solved the problem, carry on working with the radio, no smoke coming out, and then all of a sudden smoke will come out again because I didn't get the right thing. Now these are suspect capacitors, this type, but there's other capacitors here which normally don't fail, but they do fail, and they do short. I think I'm going to stop for today, and I'm going to let this kind of soak into my head a little bit. The danger here is it could have a radio with a coil not burned out, and in the course of me doing stuff, I'm going to finish the job and burn it out. And once the coil's burned out, the situation with this radio becomes very, very difficult. So we're really on the edge of a disaster here, frankly. Hopefully the full disaster hasn't happened. The other thing I'm wondering too is that this capacitor which I twisted back, which was untwisted, is that what resolved the weak shortwave? Somebody discovered that if you untwist this thing, the shortwave comes back to life. Wouldn't bet on that one, but I don't know for sure. Okay, lots of stuff to roll around in my head. You have a good day. I'm going out in the heat and the sun, play with my cats, and do probably some yard work. Take my mind off this radio for a while. Thanks a lot for watching, and see you on the next video.